So in today's video, we are going to be taking apart the Zyber 8S. So here we have the Zyber 8S, and this is a miner that we've never taken apart before, but what we want to do is clean the whole, exterior, and then also we need to replace the thermal paste on the bottom of it. We also have fans here. The only thing that I would have liked to have done is replace the fans at the same time. But as you can see, there is quite a lot of screws underneath here that we need to take off. And then we also need to take off all of these as well to actually get down into the board. But I was thinking what we could do is also just take the top off and then take the heatsink off, so we don't have to mess around with these stilts that we have by here. So the main aim of this video is just to clean everything up, replace the thermal paste, and then get it back running, just to kind of show you guys how I would do it, and you can get a look at the board underneath and all the chips underneath as well. So let's get into taking apart this. But before that, I'd like to thank the sponsor of this video, Crypto Miner Bros. Since 2018, CryptoMinerBros.com has been the premier site for top-tier crypto mining hardware, earning the trust of miners across the globe. The prices displayed on their site cover shipping and DDP straight to your doorstep, ensuring no unexpected costs at checkout. They deliver to over 100 countries and even provide lower invoicing options to help you cut down on customs fees. Payment is a breeze with options like direct bank transfer or cryptocurrencies including Bitcoin, USDT, or Ethereum. With over 250 ASIC options, they stock some of the channel's favorites like the bitaxe Touch, and the Avalon Nano 3S. Join tens of thousands of happy customers who rely on CryptoMinerBros.com for dependable hardware fulfillment, clear pricing, and a top-notch service. Check out CryptoMinerBros.com today, link in the description. So as I said, the first step is going to be taking off this part, which is connected to these rods that you see here, and then they are connected into the bottom by here. So we need to take off all of that, and then that should expose the board underneath there. The only thing about this is that if you see there, it does have hex bolts, so we're gonna need to get a different screwdriver, and then these also have, if we flip it up, these have a different hex bolt, and then these are just regular screws by here for the fan underneath. So as I said, first thing we're going to do is just take the plexiglass off, and then we'll go from there. So we've taken off the plexiglass at the top. It just came in these little screws, so these would go down into these rods here, and this was a little cover that you have, so it goes through there. And then the next part I think is going to be just taking these off, which if I'm feeling it right now, it feels like they just screw off kind of naturally. So as you can see there, all we need to do is unscrew all of these, and then I think next step past that is going to be unplugging the fans and trying to get this heatsink off. So this is also a different bolt. If we look here, I gotta be careful because it might fall apart, but this is also a different bolt for the heat sinks right there, and we're going to need to find a different screwdriver, and that just came out from this right here as well. So that goes through on the bottom like that, and then you have the little thing that secures the plexiglass at the top. So that's what we need to do. We need to remove all these, and then we're probably going to remove all the fans, so we can do that right now. And then we'll look at taking the heatsink off. Okay, so we've discovered that to take the heatsink off, you actually need to get rid of the bottom as well. So we've unscrewed these by here, and the screws are by there. And then we just need to take this off as a whole thing. So we need to undo the screws that are on the top side. So there's going to be one by there, so there's a nut by there and by there. And then we also need to take the heatsink off by accessing it underneath as well. So that looks like, I don't know if you can see in there, but there's a screw underneath there that we need to take that off. a screw under there, and then a screw in there, and the last one is by here. Then you have the ones on the back which screw through here, so you can see those two screw through there, and we need to take those off as well. So it's a bit of a meticulous process to get this whole thing disassembled then reassembled, so I wouldn't recommend doing it, but this is what we've been using. It's like a whole set of, I don't know, 20 ones that you could use that are different shapes, and they have the hex nut on them, which is like that. So that's the main one that you need. I don't currently have a link for this because I bought it ages ago, but I'll try find something similar on Amazon and link it in the description. But yeah, we need to, firstly, I think we're going to go with getting these two off, as you can see there. So we can get those two off. We can technically get these two off as well because we can see them under the fan. So we can grab them, and then these two are the main ones that we need to actually get access to underneath. So we need to take these two off first to see these two, and we can just access this on the back of the fan. So we don't actually need to take these two parts off, but we might as well because it'll make it easier overall to then reassemble it. So I'm going to do all of that, and then we'll come back when we're about to lift the heatsink off. Okay, so here we have it. This is the Zyber 8, everything underneath it. So as you can see, 8 chips, and we'll clean them off in a minute, but we decided to take everything off. We have, I think these are the voltage regulators on the back here, and then we have this massive heatsink right here with obviously copper running underneath, and that is kind of aligned with this. So I'm assuming that these two chips, based on where the copper is here, is a lot better in terms of the temperatures than these two, because they only have 2 lines running, but these 4 chips right here have 4 lines running across them, so the heat is a lot better. And this is a massive heat sink, but it does have copper, which is good because then, you know, copper is a better conductor than aluminium. So this is the whole board that you're seeing. It's not too dissimilar to a Nerd Q-Ax underneath. There's not really much I can kind of explain about it. We are mainly trying to clean it all off. The only thing that I couldn't get off was these bolts by here. I don't know why, but these are too small. I can't fit any one of these around it. I don't know what they're called, but couldn't find one that was small enough to actually get that and grip it. But if we actually take the camera off here, you can see how much parts we have. So we have all of the things from the plexiglass, them, the rods, the plexiglass, these 2 shiny chip hub things, 2 screws, or these are screws for the fans, screws for the actual these things, stilts. We have the other 2 stilts there, the screws for the heatsink, and that's pretty much it. And lastly, the back fan right there. So as I said, this video is mainly to clean the thermal paste and replace it. So let's actually get onto that. First thing we need to do is clean all this off. That's going to be very easy. We're just going to go in with something like a dish towel or a replaceable dish towel, and just take that all off with some isopropyl alcohol. Boards under, or the chips underneath here, with some Q-tips, and we're just going to take off most of it dry, and then we'll hit it with isopropyl alcohol after that. So because we do so many of these, we have basically a liter of isopropyl alcohol. Make sure that it is isopropanol alcohol, so propan-2-ol. The other ones you can use denatured, but it's technically corrosive if it is. So I would use that one just to clean everything off. So first thing we're going to do is clean this, which we can do right now. So the good thing about this is that you have a spray bottle, and we're just going to spray this and then take off most of it using that. So we just come here. My kind of way that I'm going to do it is just come like this and basically make sure that you have all of the isopropyl alcohol covering, and then hit with basically another layer after that. So just fold it in half and go again. So this part right here is not going to be the cleanest part, but this is just to mainly get most of it off so that we can start actually cleaning it properly. So you can see that a lot of the thermal paste goes into the gaps in the heatsink if we try zoom it in here. So you can see these white edges right here, that's where the thermal paste is actually collecting up in there. So we're going to try to get all of that out as well. So you can see on that there's a load of thermal paste. And we're basically going to be doing the same method for the board as well, and then we'll do a little finer cleanup with the board, but obviously we'll show you us cleaning the board. But the heatsink doesn't have to be too good. Like, we can still leave a little bit on there. It's mainly on the chips that we're going to be focusing. So this looks kind of okay. We still got some in the cracks there, so we can try grab that out with a Q-tip or just even scrape a little bit out. We'll decide later on, but that's mainly how I would take it off. It's looking kind of alright. It's fairly clean, but we'll do a little bit more on the back end whilst we're not recording. And then we're going to be doing the same thing on the board. So what I'm going to be doing is just taking the isopropyl alcohol and just carving around a little bit with one of these just to take off the bulk of it, and then we'll go in with a Q-tip afterwards. Okay, so there we have it. Fully cleaned. We'll just zoom it in for you because it's a little bit easier. Fully cleaned chips, as you can see right there. They all have a bit of artifact in on them. There was a lot of thermal paste on them, so that's a very big concern, because the thermal paste was basically cracking on it, which was interesting to see. But we can try get a close up. You can see in here it does say BM1368, BM1368, BM1368. You can kind of see that there's stuff on there which we can't actually get off. I don't know if this is a problem that people have, but there's stuff on that one we can't get off. There's maybe stuff on this one. I can't really see. This one, there's definitely stuff on there. Like, there's little cracks on there, which are concerning. I've never seen a chip like that before, but maybe it's just because of how long they've been kind of doing work, I guess. But that's pretty much it cleaned. The only thing we need to do now is actually add the thermal paste. So let's grab the thermal paste, and then we'll show you. We'll also turn the light on because it's a bit dark, or getting dark in this room. So that should be a little bit lighter now. And today we are using MX6. So I'll leave a link to this in the description if you want to go get it as well. What else am I leaving a link to in the description? I'm going to try find you one of these to leave in the description. I'll leave the isopropyl alcohol as well in the description, because, you know, people are sometimes scared, or newcomers might be scared of what they're actually getting. So you can just get exactly the ones that I got. But yeah, this MX6 is probably the best one that I've used so far on thermal paste. There might be a better one, but the thermal paste doesn't really matter too much necessarily, as long as it's a high quality one. It's all going to function the same. There's not going to be too much of a difference between, for example, the MX6 and the MX4 from Artex. So as we were kind of looking at it, this had a lot of thermal paste on the chips, and I'm wondering if that's kind of one of the reasons. The temperatures are actually pretty good, so I don't really think that it's much of a difference, but it looked like it was caked in thermal paste, because probably the heatsink, you're trying to deter away from that heating up, because it's such a massive heatsink that you probably don't want it kind of heating the chips up too much. And there's only 2 fans on it, one on the top and then one on the bottom. But we're going to go ahead and just put kind of a little bit more than we'd regularly do, just to ensure, or kind of make sure that we're not really ruining the chips, because I don't want to have to turn it back on and then it just overheats out of nowhere. So it'd be good if we could actually get it right the first time, and then we don't have to go and redo it. So I'm just going to put them on real quickly here. So that is pretty much my best try at it. We have got some thermal paste around the edges, but we try to keep them as small as possible without kind of going too overboard on it. But it looks like that will be enough, and we're trying to go for a rice grain size. That's what everyone says. I'm no master at putting thermal paste on, so this is what you get. And then the next part is going to be reassembling it. So the main problem that I think we're going to have with this is that when we actually go to put on the heatsink, it is going to slide around. I think that's what they were accounting for when they actually made these, was that the heatsink slid around a little bit. All we have to do is get basically these two that you're seeing here, so these two ones right there, solid in place, and then the rest of them, I don't think it will move past that. But we're going to kind of have to do that in tandem with each other, or we could go for these two or these two. I'm not really sure which one we want to go for yet. It's going to be quite hard to actually ensure that it doesn't slide around too much when we then go to put the heatsink back on. So we're going to have to work around that, but I'm going to put that on and reassemble it back up, and then we'll do a turn on. I didn't actually record the temperature, which is really stupid because I should have recorded the temperature before, but it's not really a test of if the temperature drops or not. It's more of a showing you guys how to do it if you have one, so that it's less daunting to actually go and do it. So we're going to put it all back on, and then we'll come back when everything is basically all assembled, and we'll do the final turn on, see what temperatures are, and then maybe we'll look back on an old video and see if we can look at the temperatures from there. So I'll join you when that is all put together. So we are finally back, and this is fully assembled now. The only thing that we do need to do is actually screw this fan in a little bit more. So that's the only problem, is lining everything up, because this is such so many moving parts within there. You kind of can't line it up without using the plexiglass at the end. So you need the plexiglass to basically line everything up for you, and then should have everything. We'll just make sure that everything else is tightened by here. Don't really know how we're going to do this, but let's do it like this, because we can plug it in and then kind of show you the... Okay, so we have the power supply here, and we just plug it in like that, and it should start up. Perfect. Now I think the last part is going to be letting it run for a little bit and then checking the temperatures. We'll go back on an old video in a little bit and see what the actual temperatures were, but this should be climbing soon, hopefully, if everything has been put back together properly. So we got 38 degrees or 38 on the fan. We have 25 degrees here. I don't know if you guys can actually see that, but let me zoom it in and bring it there. So just connected to solohash.co.uk. It's 4 terahash. Shares are good. Target difficulty is 699G. Just move that into frame here. Temperature is 29. That's obviously going to heat up, but we'll let it run for about an hour or two, and then we'll come back onto the computer and do a comparison. So I'll see you then. So here we are on the dashboard. There hasn't really been much change. We let this run for a little bit. There was something weird that we saw here, which is the asic temperature drop from around 47 all the way down to -1 degrees. I don't know how that happened. It might have been to do with the sensor on the actual chips, but it seems to be running pretty fine past that. The efficiency around 16.41, but average is 17.4, which we kind of saw previous. I don't think it's really done much of a difference. So if we go here, you can see that in the last video, so when we had this, our power consumption was 86.5 and it's currently 85.3, so slightly lower. We got the same overclocks and the same input voltage, of course, and then the asic temperature is 48.3 and the asic temperature here is 48.7 with a voltage regulated temperature of 52, and this one is sitting at 51 if you see it there. I don't know what the fan speed is, 51% there and 51% here, So there's not actually that much difference. Maybe a 1 degree drop on the voltage regulator, half a degree on the asic temperature. I also don't know how it's recording the asic temperature. That is something that we kind of need to look into. That's actually pretty good efficiency right there. But when we're going over to, where would it be, logs, and then show logs, it doesn't look like anything is wrong on here. If we stop scrolling there, it just says, you know, everything is good, chip 6, chip 8. So it seems to be that everything is functioning properly and nothing's really bad that's happening on here. So that's the main thing that I was kind of worried about, was that it would not start up or one of the chips would actually fail. But as I said, the temperature difference isn't really too much of a difference at all. And maybe it's to do with how the asic temperature is actually measured, potentially, and the voltage regulator, how that is actually measured. Could be to do with the firmware that is actually looking underneath. But overall, as long as it keeps or continues to keep working, then I really have no problems with it. It's actually been a great miner, so we could eventually start upping the terahash on it to where we go here. It would be in settings. So currently we're at the eco mode right there, which is just these overclocks that you see in here. So 490, 1166, and then we have screen turned off. But this is just in the eco mode. I think maybe we'll update the firmware as time goes on, and it may give us a different calculation for the heat here. That's the one thing that happens with a lot of these multi-chip miners, is that you don't really have the best asic temperature kind of target that you're trying to hit. Because even with the Nerd Q-axes, I know a couple of the versions of the firmware was not really targeting the correct temperature. But with the bitaxe, it's one chip, so you kind of know what the temperature is on average. And then you have things like the Zyber 8, which has 8 chips underneath. So you're trying to find an average of the 8 chips. So this might actually be a way better number compared to the 48.7 that we had in the last video. It's just an average across all of them. So that means we had to drop the temperatures of every chip on average downwards. But overall, that's the whole video of me taking it apart. If you have any questions of how to take it apart yourself, if you do have one, then let me know in the comments. I believe you can get one of these from Tiny Chip Hub. I'll leave also a link for that in the description below if you want to go check it out. We have the Zyber 8S, but there is an updated version which I would suggest you go for, which is the Zyber 8G. So if you did enjoy, make sure you like the video and subscribe for more content like this.